I want to drive you into the dual of this SDP representation. We just proved about state discrimination that SDP was really useful because we can generate to the n case, while the Olivo-Elstrom theorem that we can see in quantum chain theory, it's just like for two states. And so in reality, if you remember what we had about, we had the SDP, like the primal of it having been written like this, because Alice in the states rho x with a probability px, but Bob's needs to use a measurement, and so we need to take the trace of it to take the better of all the measurement, and we need to respect those two constraints, because of the fact that we have like a P of M, and we need to respect the P of M being semi-positive definite, and some of them being equal to the identity. But so if we have the dual, the dual will be so let's take like three states, because to illustrate, because so you have for example your first state, which is p1 like probability p1. You have also your second states being like p2 ratio of having 2 by the state itself, and third, for example, p3 because it takes 3 states, because 2 can be represented by the Olivo-Hillstrom theorem, but here we need not only this, we need 3 states, we need the SDP. And so we see the constraints here, all of them should be semi-positive definite, so it means all of them should be into this, like a big stuff called, for example, which represent this is just to represent that mx is a semi-positive definite, it's a kind of semi-positive definite matrices. And so if you check about this, you extend all of them just to have an overview, you can see in reality the command point is here, that's the command point, and so all the feasible y, which will be the solution of the dual, so that's the feasible part of it. And if you will calculate the dual, and so you will understand it. So if I either a line like this, and it's called trace of y, because the dual, you will see it's equal to the trace of y, then the more your line goes down, the more you have a minimum about this trace, and the better discrimination you have the optimal measurement for discrimination, and the goal is to go the slower. And yeah, so in reality, we search the mine of y, search that trace of y, search that y is semi-positive function of the probability of px. Yeah, so yeah, you can understand it, but if you want, we can derive it. So if we retake the stuff, we have maybe I'll do another video for doing it for you.